Hello everyone. Hope you all are doing well with your best of health. Again, we came with one more video. Here we are going to discuss about previous year NEET question for the chapter Unit and Dimension. A few more questions we'll discuss here. The very beginning question here it is the dimension of epsilon naught mu naught to the power minus 1 by 2 are they given. Simple. Try to reform this one. The power of 1 by 2 is there. Now I'm writing that one in terms of in a denominator mu naught epsilon to the power plus 1 by 2. This plus 1 by 2 is nothing but under root. Basically, you might be see this way equation. It is actually nothing but speed of light. Correct now? Speed of light means it is nothing but the dimension for speed of light is L to the power 1, T to the power minus 1. Correct now? So the correct option will be option C. Right? Next question. The density. Yes. The density of a material in CGS system of unit is 4 gram per centimeter cube. In a system of units in which the length is 10 centimeter and unit of mass is 100 gram, then the value of density of the material E is there asking. Now we have to convert from one system of unit to another system of unit so that we can go with here N1 U1 is equals to N2 U2. In a first system of unit, the number is actually 4. The unit is gram per centimeter cube. In the next system of unit, the number we have to calculate, the unit they are saying here, actually mass will be measured in gram, that is 100 gram they given, divided by centimeter cube. It is nothing but length they given. Now we want to write this one in terms of like a volume. For volume, it will become 10 to the power 3. It is nothing but 1000 centimeter cube. So 100 tens it will be cancelled. Gram will be going to cancel both the side. So here it will be 10. 10 will comes to left hand side means it is nothing but 40. It is equals to N2. So the correct answer is C. Means one system to another system of unit. If you if we are actually solving problem here, actually unit they will going to change whatever they want. Okay. For example, I will give here 10 centimeter instead of 10 centimeter. I will say the length is measured in terms of like 5 centimeter. Mass is measured in terms of 10 gram. Okay. That time you need to substitute the value in a unit and you will get the answer. Okay. Next, the dimension of 1 by 2 epsilon naught E square, where epsilon naught is permittivity of free space and E is the electric field. Might be you see this equation in capacitor. Correct now? You might be know about energy per unit volume. That is nothing but energy density. Correct now? It is equals to of epsilon naught E square. So try not to solve the equation dimension from the right hand side. Try to solve from the left hand side only, because the diamond any equation any physical quantity which we will derive means it must and should be like a left hand side and right hand side should be balanced with the dimension. For that reason I'm suggesting here, hence it will be energy per unit volume. Energy means m l to the power 2 t to the power minus 2 divided by volume. Volume is nothing but here L to the power 3. If L to the power 3 will comes to numerator, M L to the power minus 1, T to the power minus 2. So check the answer. It will be matching to B. Next question. A student measures a distance traveled in a free fall of a body. Initially at a rest, means we are dropping on object, the scenario, in the given time. He uses this data to estimate G, means okay, now to calculate G. Okay, the acceleration due to gravity. If the maximum percentage error in the measurement of distance and time are. In distance measurement, E is the maximum error. In time, it is E2. Okay, means for example, if distance we are taking as a h, means we are writing here delta h by h is equals to E1 and delta t by t is equals to E2. This is what we need to substitute and we need to calculate the answer. The percentage error in the estimation of G. Basically, for freely falling object, the time of fall, it can be written as under root of 2h by G. Now we need to calculate the error value occurred in the estimation of G. So that first turn this equation to G. First square this one, T square is equals to 2h by g. For g, if I'll make a function, so it will be 2, there is no percentage error in a 2, and h divided by t square. I can write here delta g by g. This is what actually I need to calculate, is equals to 2 times 8, leave the 2, there is no problem. Delta h by h plus t to the power 2 if it is comes to numerator minus 2. Okay, even though minus, we need to write here plus because we are adding the error. For that reason, I can write here 2 times delta t by t. What is delta h by h? Basically, delta h by h is even. Here the given, na? And plus 2 times delta t by t is nothing but e2. So even plus e2. 2e2, option B. And those who are thinking like that, sir, you missed here the value of 2. This 2 doesn't have any value here because it is carried from the formula, not from the percentage error. Correct? Now, for that reason, we are not carrying. This 2 came from actually power. When we have a power, we need to shift this power, right? Like 2 times delta t by t. For that reason, I'm writing this one, not this one. Understood? Next. The dimension of a physical quantity are given by, okay, m to the power a, l to the power b, t to the power c. Then the physical quantity will be, they given four physical quantity. We need to substitute the value and we need to check which is the physical quantity will match. Okay, crazy. First question, m to the power, first option I will check. Okay, m to the power, a means 1, l to the power 0, t to the power minus 1. They said velocity. No, for velocity it is L to the power 1, T to the power minus 1. So it is wrong. Second option we'll check. Here L to the power 1, T to the power minus 1. Acceleration means L to the power 1, T to the power minus 2 meter per second square. Check once. Here A mass also the given power 1, so it is also wrong. Next, coming to the point force. For force, you will get m l t power minus 2. M to the power 1 we need to get. So here they given m to the power 0. Force is wrong. Pressure. For pressure, it is nothing but force per unit area. Force means here only written m l to the power 1 t to the power minus 2. Divided by area means l to the power 2. If it is comes to numerator, then m l to the power minus 1 t to the power minus 2. Cross check once. 1 minus 1 2, so the given option is D. Next, if the error in the measurement of radius of a sphere is 2%, then error in the determination of the volume of the sphere, basically radius has 2% of error. Delta r by r value is 2%. Okay, there are, you might be observed since from last video we have a maximum question in error calculation. Correct now? Good. And then we need to go with the volume. For volume of the sphere we have 4 by 3 pi r cube. Basically 4 by 3 pi is a constant. There is no actually error in the 4 by 3. We need to cross check with r cube only. So we can write here delta v by v is equal to 3 times delta r by r. Hence delta v by v we need to calculate. So delta r by r value is nothing but 2%. So we will get here 6% error in the volume measurement. Next question. Which of the following physical quantity parameters have a same dimension they're asking? Interesting. Here they told energy density, energy per unit volume. Now I calculated here energy per unit volume. Okay. And then refractive index, there is no dimension for this. And next to that, actually, dielectric constant. I actually saw this dielectric constant from Coulomb's law. Okay. From there, I got the answer m to the power 1, l to the power 3, t to the power minus 4, and a to the power minus 2. And then Young's modulus, as usually, we know that it is equals to the pressure almost. And then force is equals to BIL. Last one is magnetic field. Now, for that reason, from this equation, I written here B value. Okay, B, we got answer m to the power 1, t to the power minus 2. Correct now? So that if I'll compare from the top to bottom, which one will be matching? Check once. Energy density, m to the power 1 minus 1 t. Here it is Young's modulus. Both are actually looking same, not looking same. Basically, they carry the same dimension. I'm sorry. So the correct answer is option, right? Next, dimension of a resistance in electrical circuit in terms of dimension of mass m, length l, time t, current I would be. Resistance means we are writing the formula V by I. For voltage, we need to write these terms in terms of fundamental quantities. Then only we can able to solve the dimension. Otherwise, it is not possible. Okay, now V means it is nothing but work work done by charge, and there is a current. Charge is not fundamental, so that we can convert this one into A into T, because I is equals to Q by T, so charge will be equals to A into T. Work done means M L to the power 2 T to the power minus 2 divided by charge, we can write as A into T. For current, again 1 ampere, so answer will be equals to M L to the power 2 T to the power minus 3, T will comes to numerator, A to the power minus 2. Correct option is C. Next, velocity of a particle is given by this equation, where A, B, C are constant. The dimension of A, B, C are, they are saying. Okay, now look here. Velocity is equals to AT plus B divided by T plus C. One thing I want to say here, if V is equals to this quantity means V dimension should be equals to both of them. I will choose first term as like this. V is equals to A into T. Now I want to calculate A means V by T. Correct. Now A is a constant quantity. V is nothing but velocity by time means acceleration. Simple. A constant means A dimension should be equals to your velocity by time only. Yeah, m to the power 0, L to the power 1, T to the power minus 2. One is done. Second also I will compare. Meanwhile, before that, in second, denominator check once. Denominator T plus C, they told. If I'm adding these two means these two physical quantities dimension should be same. So that time should be equals to C. Means dimension of C must be equals to T. Two answers we got. Okay. First answer A. Second one C. Now we need to target on B. As simple as that, actually, if velocity, let me change color. If velocity is equals to B divided by T plus C. Okay, B if I want to calculate. Velocity means L T to the power minus 1 dimension. Okay, here from both, it is adding the common of dimension if I take, it is equals to time. So it is equals to B. So we'll get here L only. Means B is length, C is time, A is velocity. Means A value L T to the power minus 2 acceleration. LT minus 2 in 2 equation it is there. And B value is length. So length is here and then time is here. Option B. Next, the ratio of dimension of the Planck's constant to that of moment of inertia is the dimension of, they're asking. Simple, Planck's constant value is equal to h nu. From there, I got to know that it is h is equals to m L2 t to the power minus 1. And then they're asking moment of inertia. Moment of inertia is nothing but I is equals to m r square, mass length to the power 2. Correct now? We need to divide these two. If I'll divide these two, okay, h by I, h value m L to the power 2 t to the power minus 1 divided by moment of inertia m L to the power 2. On cancelling, we'll get here time to the power minus 1. It is nothing but frequency. Next, the dimension of universal gravitational constant R above F is equals to G mm by R square. Here G is equals to FR square by M square. On solving this, you will get here M to the power minus 1, L to the power 3, T to the power minus 2, M to the power minus 1, first option. Units of permittivity of a free space. Permittivity of free space unit they are asking. We know that well, F is equals to Coulomb's law. According to that Coulomb's law, F is equals to Q square by R square. Here q square by 4 pi epsilon naught into r square. Epsilon naught we want, that's why I made a function. 4 pi is a constant. Q square is nothing but coulomb. So I written here coulomb square divided by Newton meter square, force and distance. Coulomb square divided by Newton meter square. Option C. Next, dimension of a Planck's constant equal to that of Planck's constant equal to that of E is equals to h nu. From here, recently we solved now Planck's constant where uh, here it is m to the power 1, l to the power 2, t to the power minus 1. We'll solve this one. Why we need to waste our time again? H is equals to energy means m L2 t power minus 2 divided by frequency means 1 by time. Okay, I'm shifting this one. H is equals to m L to the power 2 t to the power minus 1. Dimension of Planck's constant is equal to that of hurry, one by one we need to calculate. It is not possible to equal to energy. We'll check for momentum. Momentum means P is equals to m into v. So mass, velocity L t minus 1. No, not possible. Momentum is not possible. Angular momentum m v r. So m L t power minus 1. One more r is there, so it will become L to the power 2. Exactly, it is matching angular momentum. Power, if you want to calculate, power is equals to work done by time. Work done is nothing but m L to the power 2 t to the power minus 2 divided by time. Time will comes to numerator means it will be m L to the power 2 t to the power minus 3 it will come. So power will not work out here. Next, which of the pair do not have equal dimension? Do not have equal dimension. First one, actually energy and torque they given. Energy m L to the power 2 t to the power minus 2. Torque is nothing but torque calculation. It is r perpendicular into f. On calculating this one, you'll get the same answer. So these two will carries actually same dimension. So they are asking here do not. So these two carry same dimension. It is not our answer. Force and impulse. Force ml t to the power minus 2. Impulse is force into time. Force into time actually impulse. So here actually we'll get ml t to the power minus 1. One more time we're going to add. Correct now? So these two are not actually same dimension they are carrying. Next, calculate angular momentum and Planck's constant. Recently, last question only we solved angular momentum and Planck's constant. These two carries the same dimension. So here I written those two. Okay, here it is. Okay, and then elastic modulus and pressure. Elastic modulus means force by unit area, change in length by area, change in length by length dimension. So whatever it will carries here, it is dimensionless quantity delta L by L. Force by unit area is exactly equals to pressure, so that it is also having same dimension. Which is not having same dimension means option B, force and impulse. Dimensional formula for magnetic flux. Flux we need to calculate. Magnetic flux is equals to B into A. Correct. Now, if I want to write B, from where I can bring means F is equals to BIL. So B is equals to force by current into length. Substitute that value here. B means force per current length into area. For force, m L t power minus 1 into area means L to the power 2 divided by current ampere length meter. So 1 meter will be cancelled. The remaining part m to the power 1, L to the power 2, t to the power minus 1, a to the power minus 1. M L to the power 2, t to the power minus 1, a to the power minus 1. Which is matching. L to the power 2, a to the power minus 1, a to the power minus 1, right? What happened? What happened? Flux, force per, correct now? Cross check. Did I made any mistake? Here. T to the power minus 2, right? Simple mistake. Option C. Force, ml t to the power minus 2. Then, good. Next to that, An equation is given by P plus A by V square is equals to B into theta by V, where pressure is P, volume is V, and theta is the absolute temperature. If A, B are constant, dimension of A will be. If A and B are the constant, they are asking dimension of A. How to calculate? Basically, dimension, if I want to calculate, means observe this one. Basically, what we received here, uh, P plus A by V square. If I'm adding these two physical quantities, these two should be having the same dimension. So that P is equals to A by V square. A dimension, if I want to assume, is pressure. Pressure already we solved, M L to the power minus 1, T to the power minus 2. Velocity, V is velocity of speed, L T to the power minus 1. On squaring this one, L to the power 2, T to the power minus 2. So finally, A is equals to m to the power 1, L to the power plus 2 minus 1 means 1, T to the power minus 4. Oh, any mistake we done? Check, check. L to the power 1 we received here, L to the power 1, there is no option matching. What is V stands for? Volume. This is what the mistake we'll do usually. Correct now in exam also. Like me, don't do. Okay. Here, this is the mistake. A is equals to m L to the power minus 1, T to the power minus 2. V stands for here volume. Volume is basically L to the power 3. Here it is square. So we need to put 2. So answer will be m L to the power minus 1, T to the power minus 2, L to the power plus 6. Plus 6 minus 1 means it will become m L to the power 5, T to the power minus 2. So correct option is option C. Then next. The density of a cube is measured by measuring its mass and length, its sides, length of its sides. If the maximum error in the measurement of the mass and length are 3%, 2% respectively, the maximum error in the measurement of density will be, basically density means we are writing mass by volume. But here they given clearly mass and length of its sides. So volume we need to take in terms of L cube. Okay. Last one question we did, like where actually volume we taken as area into length. Right now we need to take this one as M by L cube. So density will be equals to delta M by M plus 3 times delta L by L. Right. Delta M by M means here change in mass with respect to original mass percentage error they given 3%, plus 2 times length they given 2%. So it will be 3 plus 4. So it will be 7% error in the measurement of density. The dimension of impulse are equals to, basically impulse is equals to force into time. Okay, force into time. Force is ml t power minus 2 and time. Correct now? So that is ml t power minus 1. It is equals to that of, oh, very good question. First one is pressure. Pressure means it is nothing but force by area. Check ml t power minus 1 force and that of area L to the power 2. If it is comes to numerator, m L to the power minus 1, T to the power minus 1. So it is not matching. First option is wrong. Galat hai. Second question, linear momentum. L is equals to mv r. Mass for velocity, L T power minus 1. For radius, one more length, L square. So this is also not matching. Force is equals to ml t power minus 2. So it is also not matching. Third one. Coming to the fourth one. Fourth one says here angular momentum. Angular momentum L is equals to mvr. So m already over na angular momentum. Or it's a linear momentum. Che, we did mistake. Okay na. This is fourth option. Oh, actually, I'm doing mistake. Okay, let's will be second one. Linear momentum means P is equals to M into V. Mass is M, length time to the power minus 1. Exactly matching. So the impulse is matching to linear momentum. Array, no need to calculate also. Basically, what is impulse? Impulse is nothing but change in momentum. change in momentum we called as impulse, that is force into time. Okay, momentum dimension is matching to impulse, that's all. Next, which of the following dimension will be the same as that of time? Shabash. Here we need to solve. Time we need to calculate, where L stands for actually inductance, R stands for resistance. We'll solve first one by one, then we'll match. Okay, L, inductance. For inductance we need to solve the dimension, means we have two simple equation, that is EMF will be equals to L di by dt. From this actually I can define a inductance value. EMF means volt, time will be comes to here second divided by current, correct now, is equals to inductance. For volt, this is the basic formula. Volt we can write as work done per unit charge, and then for time, ampere. For second it is time, correct huh? And then again work done, m L2 t power minus 2. Zoom this one, if it is not visible, it is available in Zoom or YouTube. And for time, one more time if you multiply means it is plus minus 1 divided by charge can be written as ampere into time, and one more ampere, it is ampere square. If it is time will comes to numerator, then its value will be increases, so that it will come here m L to the power 2 t to the power minus 2 a to the power minus 2. So it will take a little time, just be in a patience. Okay, for inductance we got it. Inductance is equals to m L to the power 2 t to the power minus 2 a to the power minus 2. In a similarly, we have to calculate for capacitance. So capacitance C is equals to Q by V. We'll do one thing. Q divided by V means work done by unit charge. So Q square. Q basically we are writing in terms of ampere into time. So that we can write here ampere square into time square divided by work done is nothing but m L2 t to the power minus 2. So m to the power minus 1 L to the power 2 t to the power minus 2. If it is comes to numerator minus 2, it will become plus 2, and t to the power plus 2 already existed, ampere to the power plus 2. So it will become m to the power minus 1 L to the power minus 2 t to the power 4 a to the power plus 2. M1 minus 1 L to the power minus 2 will write here. Capacitance is equal to m to the power minus 1 L to the power minus 1 t to the power plus 4 a to the power plus 2. Okay, for sequence exactly matching. Good. Next to that, actually resistance is pending. Resistance, if I want to calculate, resistance is equals to work done by current, not work done by current, volt by current. Voltage is nothing but work done by unit charge into current. Work done m L2 t power minus 2 divided by charge is ampere, time, one more current, ampere will be square. So it will become m L to the power 2 t to the power minus 3 a to the power minus 2. Okay, we'll write that value for resistance m L t a, m to the power 1 L to the power 2 t to the power minus 3 a to the power plus 2. Now we'll cross check one by one, substituting in the form of format what they given. Okay, first format the what they given, L by R. What is L? M L2 t power minus 2 a to the power minus 2 divided by R, m L power 2 t power minus 3 a power plus 2. Okay, here m cancel, L cancel, a will comes to numerator means it will become 4 t power 1 a power 4. So it is not matching, they're asking time. Second equation, c by L. C what they given, m power minus 1 L power minus 1 t power 4 a to the power plus 2 divided by c is nothing but over L m L to the power 2, T to the power minus 2, A to the power minus 2. So here also it is not matching. Next one is LC, multiplication. Option A not matching, option B not matching, option C not matching in the sense and dividing that one, we should get the same answer, right? For that reason I'm suggesting. Okay, just a minute. Sorry for the small disturbance. Okay, next L and L into C. L, what they given basically? M, L to the power 2, T to the power minus 2, A to the power minus 2. Into C. C is M to the power minus 1, L to the power minus 1, T to the power 4, A to the power plus 2. Here M will be cancelled, L will not cancel. So this is also not matching. Coming to the last one. Okay, option D. R by L. What is R? M power 1, L power 2, T power minus 3, A power plus 2. Correct my point. And then divided by inductance. Inductance value, how much they given? Check once. Inductance, where it is? First one. M, L to power 2, T to the power minus 2, and A to the power minus 2. So it is also not matching. Where did we made mistake then? Here also M cancel, L cancel. T to the power minus 1 it is coming. A to the power 4 coming. The answer came here A to the power 4 wrong. Did we made any mistakes? R by L, L by R. Check. Inductance minus 2, right? Yeah, it is minus 2. Anything wrong in this equation? Check, cross check. We'll toss it with one more time inductance. EMF is equals to L di by dt. Correct now? So L will be equals to, come on, volt second by ampere. Volt is nothing but work done by charge second time divided by ampere. So work done M L2 T power minus 2. Here one means minus 1. Done it is divided by ampere square time. Okay, it will come M L to the power 2 T to the power minus 2 ampere to the power minus 2. So inductance will be equals to M L to the power 2 T to the power minus 2 ampere to the power minus 2. If I'll take R, L by R, if I'll do means L by R means L, here only we written M L to the power 2 T to the power minus 2 ampere to the power minus 2 divided by R value we got here M L to the power 2 T to the power minus 3 A to the power minus 2. Exactly, look, here we made a mistake. Cancel, length cancel, yeah, ampere also cancel. T to the power minus 3 will comes to numerator means it is plus 3. So L by R will be equals to dimension of time. A small mistake. We made here mistake. Okay, now it is plus 3. It is minus 2. Correct now? So correct option is A. Which of the following is dimensional constant? Dimensional constant. Relative density. It is nothing but density of the object, any object with respect to water. Okay, first. Next one is the gravitational constant. Then refractive index, Poisson's ratio. They are asking which of the following is dimensional constant. Dimensionally it should not carry any value, which is that they're asking. Relative density, yes, it won't carries any values. Gravitational constant, it carries the dimension. Okay, m to the power minus 1, L to the power, how much we have received over there? 3 I think, and t to the power minus 2. Well, let's check. G is equals to f r square by m square. So m L to the power 1 t to the power minus 2 divided by L to the power 2. Yeah, no, m to the power, okay, and then here r square is L to the power 2. Here m square, that is m to the power 2, m to the power minus 1, L to the power 3, t to the power minus 2. Yeah, exactly right. Refractive index, obviously it do not carries any kind of dimension. Poisson's ratio also do not carries any dimensions. Which of the following is dimensional constant? Dimension with constant is gravitational constant. Next, dimension of R and C. Recently we solved the R and C values right here. Yeah, where it went. Yes, exactly at this point. R value we got m L2 t to the power minus 3 a to the power minus 2. We'll write here R value m L2 t to the power minus 3 a to the power minus 2. Capacitance is nothing but if you want write one more time, q by v is nothing but q by work done by charge again. Charge square means a square t square, m L to the power 2 t to the power minus 2 is work done. So on solving capacitance, you'll get m power minus 1 L to the power minus 2 t to the power 4 a to the power 2. So multiply these two, which is actually matching to that, you need to solve the answer. Okay. Next, the percentage error in the measurement of mass and speed are 2% and 3% respectively. The error in the estimation of kinetic energy will be, basically kinetic energy means we're writing of mv square. We need to calculate error in the measurement of kinetic energy, that is 1 by 2, there is no error, delta m by m plus 2 times delta v by v. Error in the measurement of mass, they given 2% plus 2 into in the measurement of velocity 3%. So it will become 6 plus 2, 8%. So option A. Okay. Na? Next, which of the following has a dimension of pressure? Pressure dimension, pressure is equals to force by area, nothing but mlt power minus 2 divided by L to the power 2. So ml to the power minus 1 t to the power minus 2. Option B. Next, the turpentine oil flowing through a tube of length L and radius R. The pressure difference between two ends of the tube is P. The viscosity of oil is given by something. What P is equal, N eta is equals to P into R square minus X square, where V is the velocity of the oil at a distance X from the axis of the tube. The dimension of coefficient of viscosity, dimension, while writing whatever the formula is there now, based on that we can write. Okay, here the values are like uh, P stands for pressure. For pressure we recently written m L to the power minus 1 t to the power, look that here, minus 2. Correct now? These two physical quantities, if you're adding or subtracting, both carries the same dimension. Hence, it is length. So length to the power 2 divided by 4 is constant. V stands for velocity or speed of that light. Speed can be written as L t to the power minus 1. Again, one more length. Correct now? Here, length cancel. T power minus 1 cancel. Here, minus 1 is pending. So answer will become here m L power minus 1 t power minus 1. M L power 1 t power minus 1. That's all. Then next, the time dependence of a physical quantity given by P is equals to P naught exponential to the power minus alpha t square, where alpha is constant and t is the time, the constant of alpha. Basically, alpha value is constant. This constant of dimension we need to return. Here, whatever the exponential function is there, now exponential function do not carries dimension. Dimension is 1. So that we can write directly alpha t square is equals to 1. So we need alpha, it is nothing but 1 by t square. Alpha dimension will be equals to t to the power minus 2. Option B. Next, Similar question, P represent radiation pressure and C represents speed of light. S represent the radiation energy striking per unit area per second. Non-zero digits X, Y, Z such that P to the power X, S to the power Y, Z to the power Z. Dimensions are dimensionless. Okay, now look at here. They given radiation pressure P. Radiation pressure or pressure? It is nothing but pressure only. A dimension will be equals to pressure. That is m l to the power minus 1 t to the power minus 1, correct now? And the speed of light c is equals to l t power minus 1, and that S represents radiation energy striking per unit area per unit time. Oh, S is nothing but energy per unit area per unit time. It is nothing but intensity. ml2 t power minus 2 divided by area l to the power 2 and time t. L power 2 cancel, so it will become m t power minus 3 is the dimension for intensity. Correct now? They are saying this physical quantity it has a non-zero powers here. Those are dimensionless. If you multiply all together, it will give the answer in terms of dimensionless. Okay, just again. Okay, sorry. It's a dimensionless. So we need to substitute the values here first. First point here actually for pressure it is m l to the power minus 1 t to the power minus 1, and next to that s value here uh here m l to the power 0 t to the power minus 3. This is x, this is y. For c it is l t power minus 1, z is equals to dimensionless means m to the power 0, l to the power 0, t to the power 0. Correct now? We'll write this format in terms of mlt first. Okay now? Now if I'll bring here mass, length, time. Okay, first point. Where it is here. M to the power first quantity x. In the next quantity plus y. In third quantity there is no mass. Next length to the power minus x and plus z. Next time to the power here minus x minus 3y minus z is equals to m to the power 0, l to the power 0, t to the power 0. Right, my point. Next to that, we need to compare both the sides. So x plus y, mass 0, so 0 answer. So x is equals to minus y. Means whatever the y value it will come, it is equals to minus of x. Crazy. Okay. Next equation will be here minus x plus z is equals to also 0, and then x is equals to z. X is equals to z, and the third equation crazy, equation number 1, equation number 2. I'm writing that in our next equation. Next, there's no page. Okay, we'll write here itself. Third one, what it is actually, minus x minus 3y minus z is equals to 0. We'll do one thing. We'll write all this in terms of x and y. Then might be we'll get the answer. For example, here minus x means x value minus y. Minus into minus plus y minus 3y, and then minus z is equals to 0 now. Now do one thing, y minus 3y minus 2y. Okay now it will become minus minus 2y is equals to z. Okay, z value became here minus 2y. Okay, similarly we need to calculate and take the ratio, you'll get the answer. Okay, I help you till now, just go with that flow. Okay now, next to that, a certain body weighs 22.42 gram and has measured volume is 4.7 cubic centimeter cube. The possible error in the measurement of mass and volume are, mass is this, volume is this one. The maximum error the density will be. Density means mass by volume. The density how you are writing? Delta m by m plus delta v by v. Sorry, delta v by v. Now delta m by m. Delta m where it is? Here it is delta m. 0.01 gram divided by original mass is 22.4 gram plus volume is 0.1 cubic centimeter divided by 4.7. We want to calculate this in terms of percentage error. So multiply by 100. Solve this, you will get the answer. Okay. Next. Question. Huh. The dimensional formula for permeability of a free space, that is mu naught they are asking. The mu naught value simplest form we will solve from the equation. Force per unit length or current carrying two wires formula is there na? Force is equals to mu naught by 4 pi 2 I1 I2 by the length between the distance between two wires into length on each segment. How much force is acting? From here we can easily calculate. Okay. Next to that here we want mu naught. For that reason I will make function as mu naught. So force and 4 pi is constant. Distance divided by ampere square because time and length. Okay na? Here length will be cancelled. So m l to the power 1 t to the power minus 2 a to the power minus 2 is a dimension for mu naught. Option A. Next, in a similar way, look at this one also. Here, frequency of vibration is f of a mass m suspended from a spring. A spring constant is k. Given by a relation f is equals to a m to the power x k to the power y. Okay. Where a is dimensionless constant, the value of x and y they are asking. Basically frequency na, so we can write here t to the power minus 1. A is dimensionless constant, m stands for mass, m to the power x, k stands for what they given? Spring constant. For spring constant we can write here force per unit distance. Basically f is equals to minus kx now. So k dimensionally I'm writing here force by length x. It is nothing but m l t power minus 2 l. So we can write that value here m l power 2 t to the power minus 2 whole to the power y. Next, compare the values by writing individual dimension m to the power x plus y. Here next l. Next, L to the power 2y and t to the power minus 2y. Here it is t to the power minus 1. Compare the dimension of t first. Minus 2y is equals to minus 1. So that we will receive here y is equals to 1 by 2. X we want, so that we can write that value here. X plus y. There is no mass, so it will be equals to 0. So x is equals to minus 5 means whatever the y value it is there, opposite to that value we need to write in opposite sign. So x value will be equals to minus 1 by 2. X value minus 1 by 2, y value plus 1 by 2. Option D. Next, similar question, guys. Actually, according to Newton, the viscous force acting between two liquid layers of area A, velocity gradient, this one given, force is equals to eta A dV by dx. Okay, where eta is constant of coefficient called coefficient of viscosity. Dimension formula for eta is actually dimension formula you may receive from here, or also I told na f is equal to 6 pi eta rv. From here also you may derive. Both will give the same answer. Here if I'll come means eta is equals to force by area and delta v by delta z will comes to here delta v by delta z. For force m l t power minus 2. divided by area is L to the power 2, dv velocity L t power minus 1, dz it's a length. Okay, so length cancel, one more length cancel, so answer m L to the power minus 1, t to the power minus 1, m L power 1 minus 1, t to the power minus 1, option D. Okay na? Similarly, if x is equals to at plus bt square, where x is the distance traveled by the body in kilometer, while t is the time in second, then unit of b is, where is b? Here it is b. Okay, let's do one thing. X is equals to at, right? A is equals to basically what happened here, x by t. Correct now? X distance is in kilometer and time which will be, which is in second. They're asking b SI unit. Do one thing, at dimensionally should be equals to bt square, so tt cancel, b is equals to a by t, whatever the answer you received here in a kilometer per second. For time, one more second, so b will be equals to kilometer per second square, so option C, correct. Next, which of the following quantities, which one has a dimension different from me remaining three above? Okay, energy per unit volume. It is nothing but m L to the power 2 t to the power minus 3 divided by L to the power 3, energy per unit volume. So you will receive here m L to the power minus 1 t to the power minus 2. Why it is 3 minus 2? Correct now? And then force per unit area, force per unit area m L t power minus 2 divided by L to the power 2. Force per unit area is nothing but pressure, m L to the power minus 1 t to the power minus 2. Okay, these two are same. Product of voltage and charge per unit volume, voltage into charge per unit volume. For voltage, work done by charge into here one more charge divided by volume means L to the power 3. Charge cancel, m L 2 t power minus 2 divided by L to the power 3. So answer m L to the power minus 1 t to the power minus 2. Oh, all three are same. Nice. Angular momentum, L is equals to mvr m L to the power 2 t to the power minus 1. So angular momentum is one different from all. They given in option D. How savage these people. We need to solve each and everything. Dimensional formula for self-inductance. Yes, self-inductance we can calculate by using these two formulas. I suggest this second one for easy calculation. EMF means volt second volt. Time will comes to here means second divided by ampere. From here volt, work done by charge, here it is time, it is ampere. Correct now? Work done m L2 t power minus 2, one more t will be adding here, divided by charge ampere time into one more ampere will be added here. So time cancel, m L to the power 2 t to the power minus 2 a to the power minus 2. T will not be cancelled. Cancelled. Is m L2 t to the power minus 2 a to the power minus 2. Option C. Next, dimensional formula for torque, R perpendicular to F. R, it is nothing but work done. It is nothing but equals to energy. Okay, m L2 t to the power minus 2. Option A. Next, C and R denoted by capacitance and resistance. Dimensional formula for C into R. Guys, actually I solved C also and also I solved R. Just multiply these two. C into R. C value m to the power minus 1, L to the power minus 2, t to the power 4, ampere to the power 2. And R we need to multiply m L to the power 2, t to the power minus 3, a to the power minus 2. So m cancel, length cancel, power it will become power 0. Okay, and amperes will be cancelled. Here it is t to the power 4, t to the power minus 3. So what you'll receive finally, you'll receive here time. Means we got to know the two things. Last previous question we solved, L by R, it is also equals to time. Here c into r, it is also equals to time. Be careful while solving these two questions. Okay na? L by r and c by, sorry, c into r. Next, dimensional formula for angular momentum. Are many times we solved. M L t power minus 2, here 2. L2 t to the power minus 2, here option A. That's all. This is all completely around. I took 70 question PYQ in these two videos. Okay. Hope you'll all find good wavelength to solve. And moreover, I didn't solve any question. I put a actually like a topic over there, and I given a like a small wavelength how to calculate, like small energy how to calculate these questions. That's all. Okay. Thank you so much.